There it is. I think we're live. We're going. We're going. Okay, guys, here we go. We have one less exam. We have got one last exam left. 6/6/2020. Okay. All right. Our objective today is we're going to look at radian measures. Yeah.
It's 2022.
Yeah, what's wrong with me? I'm distracted. 2020. Radian measures of the, let's say, the unit circle, okay? So radians come from, and we say unit circle because unit circle means radius 1. Okay, when you see the word unit, it means 1. So we're going to look at a circle with a radius of 1. So what is a radian? Okay? What is a radian?
An angle.
It's an angle. So a radian is an angle.
Wait, why did you write radius mean?
Radius 1.
Oh.
Oh, that's a O-N-E. That's a sloppy O. So a radian is an angle with a radius of 1 and arc length of 1. And I have a picture of it here. This angle right here is 1 radian. It's about 57 degrees. Okay, so 1 radian is about 57.3 degrees. Okay, so you can have. So today, an angle now has 2 names. It has 2 names: 30 degrees or pi 6 radians. Okay, 180 degrees or pi radians. We're learning this. Okay, one angle has 2 names. Okay, one is just a rotation. 30 degrees. It's a rotation. Does that make sense? The other is an angle that is also the same as its arc length. Okay, we're going to learn about all these. So standard position, positive angle is less than 30. Okay, so all of our angles are going to come from the circle. So let me go ahead and draw a picture. Radius of 1. We know 90 degrees, 180 degrees, 270 degrees, and of course 360 degrees. Those are my degrees, and it's important this time you put the little degree symbol on it because they're degrees. We know these. We know these from way back in, elementary school. Degrees are easy. But today we want to change these to radians. So let me see if I can get a different color. I want a color that you'll see real well. Oh, how about orange? That'll work. This is going to be pi radians. That's an angle. 180 degrees and pi radians are the same angle. Same angle, just a different name. You okay with that? Turns out that if you take a string and wrap it around from here to here, it will also be 3.14 blah 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 inches long. Okay, the angle and the arc length are the same. So that means if half a circle is pi radians, then the full circle is 2 pi radians. And of course, this comes from the equation of a circumference of a circle. Circumference of the circle is C equals 2 pi r. Well, our radius is 1. So the arc length, sure enough, is indeed equal to our angle. Well, if this is pi radians, okay, 180 degrees, 180 degrees, pi, same angle. If this is 2 pi, 360 degrees, same angle. Okay, one full rotation, 360 degrees, or one full rotation, 2 pi radians. Then 90 would have to be pi halves, because it's half a pi. Same angle, different names. 90 degrees, pi halves. 270 degrees turns out to be 3 pi halves, okay? Same angle, different name. How am I doing so far? Okay? Just remember, radians are angles. They're just a different way of describing it, okay? Now, let's go and talk about just angles, okay? So, example 1a, if I want to draw a 400 degree angle, that means it's going to rotate all the way around the circle and then back again. So to show that, I'm going to draw a picture. And I know 400 is the same thing as 360 degrees plus 40 degrees. Right, I mean that's, and why 360? Because that's one full circle. So 400 degrees is 360 degrees plus 40 more. And the reason I want to do that is because to show this, I'm going to start at 0 degrees. I'm going to go all the way around at 40 more. There's my 400 degrees. So for 400, you've got to go around the circle one full revolution, and then 40 more. It's like turning the tire. You know, if you have to rotate your tires, you spin the tire around and back around, right? It's pretty simple. B, negative 100 degrees. Well, it's just rotating your tires backwards. So if I wanted to draw a picture of this, this would be like negative 90 degrees, right? So negative 100 degrees would be right about there. It doesn't have to be perfect. We just have to have it close to where it might be. We know that this would be a 10 degrees right in there. Now 15 pi fourths. Ooh. Well, let's see. 8 fourths plus 7 fourths makes 15 fourths. And you probably don't have a clue why I wrote that, but I'm going to explain it, okay? 15 pi fourths. Now, this is a radian. There's no degree symbol, and radians oftentimes will be with pi. That's a radian, which is an angle. Well, that's the same thing as 2 pi plus, well, 4 goes into 7, how many times? 1 and 3/4, right? So if I wanted to draw this and show where it is, yeah, I will slow down a second. I will, okay? This one's a little bit harder, but we can do it. Give me a thumbs up, Giselle, when you're caught up, okay? It's a little bit harder, but I know we can get it, okay? So I know this is an angle, and it's an angle on the circle. I want to rotate 15 pi fourths. What the heck? Where is that? Well, I knew 15 fourths was 8 plus 7 makes 15. Everybody agree with that? And I made it fourths, okay? 2 pi means going all the way around the circle one full time. So I know my circle is going to go rotate to here. Okay, 2 pi. 2 pi is 1 circle, right? 2 pi is 1 full circle. Now, if I want to go 1 3/4, I'm going to go another 1 pi plus 3/4. So I'm going to have 1/4, 2/4, 3/4 goes to there. That's a little bit harder to see. Yeah, okay, and I'll show it again. I'm going to show it again, okay? I'm going to show it again so you guys can see it. Here's another way to do it, okay? Here's another way to do it, which might make it easier, okay? This is pi halves, okay? I showed you this is pi halves, right? 90 is pi halves, right? Now see another way to do it, might be easier. Let's count. Let's count. 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths, 8 fourths, 9 fourths, 10 fourths, 11 fourths, 12 fourths, 13 fourths, 14 fourths, 15 fourths. Is that easier to see it that way? Want to do it again?
Yeah.
Want to do it again? I got to go 17 fourths. So if this is a half, then that's a fourth, okay? So this much is fourth. So if I got to go 15 fourths. So 1, 2, 3, 4, 5 fourths, 6, 7, 8 fourths, 9, 10, 11, 12 fourths, 13 fourths, 14 fourths, 15 fourths. You see the rotation? Okay. Is that a little easier to see it that way? Okay, it does make sense. Good. Okay, now, example 2. We're still talking about angles. It says find an angle both positive and negative that is coterminal. Okay, what does that mean? Well, same spot. Same spot. Coterminal, same spot. Okay, so let's see if I can draw a picture, okay? And you don't have to draw a picture to do this one, but it's helpful, okay? So 60 degrees is about, I'm just going to guess, 60 degrees is about there, okay? You guys all right with that?
You still have like that game that like you have to try to guess the angle?
Yeah,
What's this?
Is it basically like something like this?
it's a little bit like that. So, you ready? Watch this next one. Let me get a color.
I'm going to steal this from you, Mr. Davies.
400 degrees is in the same spot, isn't it? What did I do? 400 degrees is in the same spot, isn't it? What did I do? Thank you. Okay, thank you. Thank you. Thanks, Caden. Yes, 420. Yep. Same angle, right? Same spot. It's almost like just turn your wheel 360 degrees, okay? And, you ready? Negative 300 degrees is also the same spot. I just went backwards. Or, instead of drawing a picture, and I'll let you catch up, I want you to see the visual. So what did I do? Okay, think about this. You got your car is up on jacks, and you rotate the tire, okay? Because right now you got a nail in the tire right here. You rotate the tire around 420 degrees. Or you rotate the tire backwards, same spot. Michael.
Can't you just plus and add 360?
Yes, thank you. Because remember I said there's an easier way to do it?
Yeah.
Yeah, exactly.
That's
So
the easy way.
yeah, a lot easier. So, or instead of drawing a picture, you know that theta 1 is 60 degrees, okay? Theta 2 is just 360 degrees plus 60, right, Michael? And then theta 3 is just 60 degrees minus 360 degrees. Completely correct, Michael. Yep, I agree with you, okay? Now, if we know that, then we can do B. So let's do B the other way. Theta 1, negative 120 degrees, okay? Theta 2 is just the negative 120 degrees plus 360 degrees, right? Is that 240? Yeah. Theta 3 is negative 120 degrees minus 360 degrees, which is going to be the negative 480 degrees. Thank you, Michael. So much easier, I agree. But the visual didn't hurt, did it?
It didn't hurt.
Yeah.
This is making it a lot easier.
I totally agree. Okay, now what about these darn radians, okay? So theta 1 is 2 pi thirds, right? Theta 1. Theta 2, to find the second angle, well, what we did is we added 360 degrees, but we're in radians now. We're in radians. 360 degrees is 2 pi, right? So I'm going to take 2 pi thirds and add 2 pi, which is going to give me 2 and 2/3 pi. You okay with that? 2 and 2/3 pi. Theta 3 is going to be 2 pi thirds, and we're going to subtract. We're going to subtract 360, but not 360. We're in radians. So don't subtract 360 degrees. We subtract. Well, 1 revolution in radians is 2 pi, right? So we subtract 2 pi. Oh, common denominator, that's 6. That's the same thing, 6/3. Subtract, I get a negative 4 pi thirds, okay? Thanks, Michael. That's exactly what I wanted to get to, because drawing the picture is kind of a pain, isn't it? Okay, are you guys ready? I'll wait for you.
Give me like 10 seconds.
I will give you 10 seconds.
I know it's a little bit more.
Okay, then we're going to look at your journal in a second.
Alright, go ahead.
Okay, turn the page. Did I go too fast?
There's more.
Okay, there's more.
Right.
Okay, we're going to get it done.
Wait, can you go back real quick?
Yes, I can. I'm going too fast.
How did you go from 6/3 to...
I just need a common denominator. So I really do want to subtract these two right here. 6/3 is 2. You with me, Sophia? And then I could subtract these two, and that's 2. Subtract 6 gives me my negative 4, okay? All right. Good, Giselle? Got it? Okay, guys, ready to turn the page? Okay, it's hard stuff because it's new. Okay, now, reference angle, okay? Reference angle. So, everything we're going to do will come back to trigonometry. Okay? Everything we're going to do is going to come back to trigonometry, okay? It really is. And to have a reference angle, then we need to have some right triangle. So let me draw a picture. The picture is actually really helpful on these. (160 degrees) is about here, right? But that's not a right triangle. But here's a right triangle. Do you see my right triangle now? That's my reference angle. My reference angle is the 20 degrees. And a lot of what we're going to do with, believe it or not, this stuff, we're going to have to do with this, but you can't do trig with 160 degrees. You can't do right triangle trig with 160 degrees, but you can with the 20 degrees because we create right triangle. Okay? So my reference angle is 20 degrees. It creates the right triangle with the horizontal axis. Okay? Thumbs up? Okay, so let's look at the second example. 340 degrees. I like to draw a picture. It's just helpful for me if I draw a picture. I know 340 degrees is all the way right about here. Draw that in. There's my 340 degrees. But I need a right triangle. That's not a right triangle, but there is a right triangle right here, isn't there? You see the right triangle? Of course you do. So my reference angle is that angle here, and again, just by coincidence, 20 degrees. Okay, C is a little bit harder, but we can do it because we're smart. Am I doing okay so far? 5 pi 6. Well, what we learned is this was pi halves, and that was pi. I saw that over here, right? You guys remember that? See, I saw that over here. So that means 5 pi 6 is probably right about, it's right about there. That's an angle.
Wait, how did you get
I knew that it's less than pi, right? This would be radius. Now, I don't normally write like that, but, I mean, 3, 6, and 1/2 are the same, right? And 6, 6 are the same. So, 5 pi 6 has got to be right in here somewhere, right? So, what's the reference angle? In radians. This one's going to hurt your head. I can see it already.
What?
I'll go through this one again.
Restart.
I will. I'll restart this one, okay? All right.
Would it be 1 6?
Hold on to that. Okay, I'm going to get into that. Okay, you ready? If I take from here to here and break it up into 6, okay, think fractions, 6, okay? 3, 6, 6, 6, okay? Break it into 6. 3, 6, 6, 6, okay? So 1 full from here to here, pi, 1 pi could be 6, 6, okay? So watch my finger. Everybody watch. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. I'll do it again. We're breaking this whole thing into 6. Like slice the pie. We moved our pie last night from one.
So question,
I love it.
so if it's like the divided by like 6 or divided by a certain number, you're just doing that for like the top half?
Yeah, just the top half. And the reason I want to do the top half is because from here to here is pi.
Oh.
Here to here is 2 pi, okay? It always is from here to here is pi. Okay, so watch, I'll do it again, 6, okay? So I'm going to break this half up into 6, okay? So 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. You get that? You get that?
Yeah.
So I just took and sliced my half up into 6, okay? So Retta said then what's left over is a pi 6. That's my reference angle, is pi 6. It's an angle. It doesn't look like an angle, but it's an angle, okay? Now, if degrees and radians are the same, okay? If degrees and radians are the same, then 100 degrees is one name of an angle, and it should have a radian as well, okay? So there's this really easy conversion here, okay? If you want to convert from degrees to radians, we just take this little formula and we can convert it. One of the things we like to do, though, is we want our radians to be in pi, in forms of pi, okay? Radians should be in pi terms, should be in pi terms. I'll show you what that means, okay? Just like 5 pi 6. And there's a reason we use pi quite a bit, because we know that the circumference of a circle is 2 pi, okay? So all of our radius, that was a pi, that's a pi, that's a pi. All of our answers should be in pi if they can, okay? Put that far away. So then, check this out. So I'm going to take 100 degrees, and I'll put it right there. So I put 100 right there. So I'm going to go, okay, my radian is 100 over 180 pi. And I'm going to reduce this fraction. So it becomes 5/9 pi. These two are the same angle, same spot, different name. Same 100 degrees and 5/9. 100 degrees and 5/9. Same angle, same spot, different name. This also gives me the arc length. Right? Negative 300 degrees, we'll do the same thing. We plug that in. So we'll take our negative 300 and put it in for theta. So our radian is going to equal negative 300 over 180 times pi. Okay, I'm just using my formula here. Just plug my theta, that's my angle, into the formula. Okay, I'm going to reduce this, okay? 30/18, let's see, that should be divided by 6, right? 5, let's see, divide by 9ths, right? Divide 30, right? Divide by 6, and I get 5. Divide by 6, I get thirds, okay? 5, negative 5 thirds pi, okay? Same angle, different name. Negative 300 degrees and negative 5 pi thirds are the same angle, different name. You okay with that? One's a name in radians. It's also the arc length. Okay. And now, going to B. We should be able to go the other way. 5/6. This is a radian. It should have a degree equivalent, right? So it also has a formula, okay? It also has a formula, okay? So since it has a formula, we could just plug it in. So I'm going to take my 5/6 and put it right there. Just put it right there. So I'm going to rewrite this as my degree is equal to 180 over pi times my 5/6. Okay, and I'll step back. Let you see, okay? So same angle, different name. Same angle, different name. Okay, here's the radian. Okay, conversion. This change in degree. What do you notice first? Anybody notice something? Plugged it in. Anybody see something? Hopefully, something easy. Okay, see something easy. Tell me you see something easy.
There's 1.
Well, what do you see about the pies? You see something about the pies? Don't you guys agree the pies cancel?
Yeah, I agree.
Yeah, and then I'm just going to go, what is 5 times 180 divided by 6? So I'm just going to use my calculator quick. 5 times 180 divided by 6, and I get an answer of 150 degrees. Okay, B. Now I told you early on that 1 radian was about 57.3 degrees, didn't I?
Yeah.
So we should be able to take our formula and get the same thing. So if I take my 1 radian, and plug it in here, let's see. So my degree for 1 radian is the same thing as 180 times pi times that 1, okay? And then I'm just going to use my calculator, and 180 divided by pi is about 57.3 degrees. What do you know? Okay, last but not least. Okay? Now, arc